Okay, guys, here are your last two graphs in section 6.5, day 1, the graph of cosecant and secant. All right, remember, cosecant is the reciprocal trig function to sine. So one of the easiest ways to graph the cosecant graph is to graph the sine function real quick, because by now you should pretty much know their graphs pretty good, and then just reciprocate his ratios. So if you can picture the sine wave, sine started at 0, 0, right? And if you can think of it, it had a period of 2 pi, and we counted by pi's over 2. So 1 pi over 2. I'm doing this in pencil because I'm so afraid I'm going to not do something that I want to do, because I want to use dotted lines with this. 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, 8 pi over 2, which is 4 pi, right? And then we have negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, and negative 4 pi over 2, right? And then sine went from 1 to negative 1. Okay, so if you can picture the sine wave, and again, remember, sine of all these angles was the y-coordinate. So he started at 0, and then when pi over 2 went in, 1 came out. And then when pi went in, 0 came out. And then when negative 3 pi over 2 went in, negative 1 came out. I guess I could put dots, right? And then 0, and then 3 pi over 2, and then back to 0. So I don't know if you guys can see that, but that is what one sine wave looks like from 0 to 2 pi, right? He went up and then down and then back to 0. And then he continued that pattern. So he's going to go up again to 1 at 5 pi over 2. And then he's going to go back down to 0 at 3 pi. He's going to go down to negative 1 at 7 pi over 2. And then back up to 0 at 4 pi, all right? So again, that's what the sine wave looks like, okay? And let's go the other way. So he's going to go from 0, he's going to go down to negative 1 at negative pi over 2. He's going to go back up to 0 at negative pi. He's going to go up to 1 at 3 pi over 2, and then back down to 0 at negative 2 pi, and then keep on going and going and going. So again, that is what the graph of the sine wave looked like. So what's going to happen is, now all you have to do at each one of these angles, reciprocate the ratio that came out for sine. All right, ready? So when 0 went in to the sine function, 0 came out. So when 0 goes into cosecant, the reciprocal of 0 comes out. And what's the reciprocal of 0? If you think of 0 over a number, flip it over, it's a number over 0. That's undefined. So when 0 goes into cosecant, an undefined ratio came out. Maybe I'll use a marker now for this one. An undefined ratio came out. Okay, so the cosecant function is going to start at an asymptote. Okay, then we go to the next one. So when pi over 2 went into sine, a ratio of 1 came out. So when pi over 2 goes into cosecant, the reciprocal of 1 comes out, which is 1. Okay, so this will still be a point that lives on the cosecant graph as well. All right, then we go to pi goes. When pi went into sine, 0 came out. So when pi goes into cosecant, the reciprocal of 0 comes out, which is undefined. So that'll be an asymptote on the graph of cosecant. Okay, all right. Well, when 3 pi over 2 went into the sine function, a negative 1 came out. So when 3 pi over 2 goes into the cosecant function, the reciprocal of negative 1 comes out, which is negative 1. So negative 1 will also live on the cosecant graph. All right, now we go to the next one. When 2 pi went into the sine function, 0 came out. So when 2 pi goes into the cosecant, the reciprocal of 0 comes out, which is undefined. So there's another asymptote. Oops, got my marker. There's another asymptote on the graph of cosecant. Okay, well, when 5 pi over 2 went into the sine function, 1 came out. So when 5 pi over 2 goes into the cosecant function, the reciprocal of 1 will come out, which is 1. So this is a point that is also on the cosecant function graph. So they do have some points that are in common. All right, when 3 pi went into the sine function, 0 came out. So when, I didn't put this in, 1. So when 3 pi goes into the cosecant, the reciprocal of 0 will come out, which is undefined. So that's another asymptote that is on his graph. So he's covered in asymptotes, okay? All right, when 7 pi over 2 went into the sine function, -1 came out. So when 7 pi over 2 goes into the cosecant, the reciprocal of -1 comes out, which is -1. So this will be a point that is on the cosecant graph. All right, and then last, when 4 pi went into the sine function, 0 came out. So when 4 pi goes into the cosecant function, the reciprocal of 0 comes out, which is undefined. So yet another asymptote. All right, and then we can keep going, but I'm going to go the other way. So let's go back this way. So when -pi over 2 went into the sine function, -1 came out. So when -pi over 2 goes into the cosecant function, the reciprocal of -1 comes out, which is -1. So that's a point that is on the cosecant graph. All right, let's go to -pi. When -pi went into the sine function, a 0 came out. So when -pi goes into cosecant, the reciprocal of 0 comes out, which is undefined. Okay, so that's another asymptote on the cosecant graph. All right. All right, when -3 pi over 2 went into the sine function, 1 came out. So when -3 pi over 2 goes into the cosecant function, the reciprocal of 1 will come out, which is 1. So that's a point that'll live on both of their graphs. Okay, and then last, when -2 pi went into the sine function, 0 came out. So when -2 pi goes into the cosecant function, the reciprocal of 0 comes out, which is undefined. So there's another asymptote that lives on his graph. Okay, so it's kind of like, well, what the heck does the graph look like? All right, so we're going to have to fill in the graphs. So let's go right here. So guys, this is 0. And this is 1. So when 0 went in, undefined came out. When pi over 2 went in, a 1 came out. But there was some angle in between 0 and pi over 2 that made 1/2 come out. That point right there. So right here is where some angle went in and 1/2 came out. So think about it. When this angle goes into the cosecant function, the reciprocal of 1/2 will come out. So what's the reciprocal of 1/2? 2. So when this angle goes into the cosecant function, the reciprocal of 1/2 comes out, making it 2. So now this is a point that lives on the cosecant graph. All right. Now look over here. There was another angle in between pi over 2 and pi that also made the ratio of 1/2 come out on the sine graph. So when this angle goes into the cosecant function, the reciprocal of 1/2 is going to come out, which is 2. So now this is a point that lives on the cosecant function. So now if you can see what's happening, this wave right here, when you take the reciprocal of all of these y values, it takes this wave and flips it up. And it creates what we're going to call, well, or looks like a parabola. All right, even though it's not, but it's got that shaped curve. So now you have this curve that lives on the cosecant function in between 0 and pi. All right, let's look at the next section, all right? There is an angle that when you plugged it into the sine function, it made the ratio -1/2 come out. So when you plug this angle into the cosecant function, the reciprocal of -1/2 comes out, which is -2. So now this is a point that lives on the cosecant graph. All right, there was another angle in between 3 pi over 2 and 2 pi. This angle right here made -1/2 come out. So when I plug this angle into the cosecant function, the reciprocal of -1/2 will come out, which is -2. So now on this interval from pi to 2 pi, you have a downward opening, what we're going to look like parabola shape. Okay, so again, what happens to this part of the sine curve, when you take the reciprocal of all of these y values, it's going to flip them all down. And now this curve gets flipped like this. So technically, one cycle of the cosecant graph is from 0 to 2 pi, up parabola, down parabola, okay? And then your next one, same thing's going to happen when you get to the next section. If I take all of these y values and take the reciprocal of them, it's going to take this hill and flip it up. And it's going to be another parabola that goes up. All right? Same thing over here. If I take all of these y values and I take the reciprocal of them, it's going to take all of these y values and flip them. And it'll be another downward opening parabola. All right, and the same thing. So up parabola, down parabola, the next one would be up. All right, we can go this way. If you look at this, all of the y values that live on this part of the sine graph, when you take the reciprocal of them, are going to flip down. And now it's going to be another curve like that. Same thing on this portion of the sine wave. When you take all of these y values reciprocals, it's going to flip them over and it's going to look like that. So that is what the cosecant graph looks like. Oh, my phone is dying. Okay, so that is what the cosecant graph looks like. So one cycle of the cosecant reciprocal of sine function is going to be from 0 to 2 pi, up parabola, down parabola. And it's got 1, 2, 3 vertical asymptotes on its first cycle, okay? So again, this is what we consider to be his first cycle, okay? And it's from 0 to 2 pi. All right, so who's the domain? He's got lots of bad angles. X can't be 0, pi, 2 pi, 3 pi, 4 pi. So X cannot be 0, plus or minus, well, every bad angle is pi radians away from the next. So pi times k rotations, right? Or X cannot be integer multiples of pi. All right, the range. Well, look at your range because it's got a gap. It's going from negative infinity to -1, and then look, none of these y values come out of the cosecant function, and then it picks back up at 1 and then goes to infinity. So there's no y values that live on the graph in this entire section here. From -1 to 1, they never come out. So his range is from negative infinity to -1, including -1. Union, it picks back up at 1, including 1, and then shoots off to infinity. So it's got this big gap in its y values, okay? All right, the x-intercept, it's got to, look at it. Does this graph ever cross over the x-axis? Nope, because remember, his graph is just the parabolas, up parabola, down parabola, up parabola. It never crosses the x-axis, so it does not have any x-intercepts. Okay, the period is, what did it take to create this cycle? Up, down, up, down. It takes from 0 to 2 pi radians. So 2 pi is his period. All right, the amplitude, again, if you're going to go to a negative infinity, infinity, negative infinity, it just doesn't apply here. So NA. All right, your y-intercept. This graph is not allowed to cross over the y-axis because there's a VA on the y-axis. So there's no y-intercept. All right, if you remember, the sine function was an odd function. For every xy that lived on his graph, there was an opposite of x, opposite of y. Look at here. When pi over 2 went in, 1 came out. When negative pi over 2 goes in, -1 comes out. So this is odd function behavior, which has symmetry to the origin. Okay? VAs, tons of vertical asymptotes. Every x value that is not in his domain creates a vertical asymptote. So 0, 1 pi, 2 pi, 3 pi, 4 pi. Integer multiples of pi are all of your VAs. So x will equal 0 plus or minus pi times k rotations, or x will equal integer multiples of pi, all create VAs on his graph. All right, 4 subintervals, just like sine. We took his period 2 pi, we divided it by 4, which is pi over 2. So we create 4 subintervals on one cycle. 1, 2, 3, 4 subintervals live on his first cycle. So let me just cover that up. So look at the one cycle only. So you have, like I said, 1, 2, 3, 4 subintervals. The first subinterval is from 0 to pi over 2. All right, and then pi over 2 to pi. And then pi to 3 pi over 2. And again, these are just to help you when you go to create its first cycle. And then from 3 pi over 2 to 2 pi is your last subinterval. Okay, so now you have 5 key points again that live on his graph to kind of help you get started. The first key point is 0 undefined, even though it's an asymptote and not really a point. All right, then you have pi over 2, 1. All right, then you had pi undefined, which is another VA. All right, then you had 3 pi over 2, negative 1. And then you had your 2 pi undefined, another VA. So again, these are your 5 key points that you could use to get you started with the first cycle when you go to transform him. All right, and then just remember, his cycle starts up, down, up, down, up, down, and so on, okay? All right, well, the last one, secant, is going to be extremely similar to this one because it's just going to be the cosine wave reciprocated, except because of their shift, their asymptotes will be in a different spot. All right, so here we go. Ready? So it's really quick. Let's whip up a cosine wave. If you remember what the cosine wave looked like. Cosine started at, well, again, being that it had a period of 2 pi and divided by 4, we counted by pi's over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, which is 4 pi. And then negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, and then negative 4 pi over 2. And we went from 1 to negative 1 as well. Okay? All right, so if you can picture the cosine wave. Cosine, your coast, like your seagull, started up at 1, then it went down to 0, to negative 1 at pi, back up to 0 at 3 pi over 2, and then back up to 1 at 2 pi. So that was your first cycle of your cosine wave. A little bit off, but basically that's what it looks like. And then it continued, right? Then it would go back to 0, to negative 1, to 0, and then back up to 1. And then same thing. It would go to 0, to negative 1, to 0, and then back up to 1. And then it would start all over again. So that is what your cosine wave looked like. All right? So what we're going to do to create the secant is just reciprocate all of his y values. All right, ready? Here we go. So when 0 went into the cosine, 1 came out. So when 0 goes into secant, the reciprocal of 1 will come out, which is 1. So that's a point that lives on both of their graphs. All right, when pi over 2 went into the cosine, 0 came out. So when pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that's going to be a VA on the secant graph. Okay? All right, when pi went into the cosine, negative 1 came out. So when pi goes into secant, the reciprocal of negative 1 comes out, which is negative 1. So that'll be a point on the secant graph. All right, when 3 pi over 2 went into cosine, 0 came out. So when 3 pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that'll be a VA on the graph of the secant function. All right, when 2 pi went into the cosine function, 1 came out. So when 2 pi goes into secant, the reciprocal of 1 will come out, which is 1. So that'll be a point that lives on both of their graphs. All right, when 5 pi over 2 went into cosine, 0 came out. So when 5 pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that'll be a VA on the secant function's graph. Okay, when 3 pi went into cosine, -1 came out. So when 3 pi goes into secant, the reciprocal of -1 comes out, which is -1. So that'll be a point that lives on both their graphs. All right, when 7 pi over 2 went into cosine, 0 came out. So when 7 pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that'll be another VA on the secant function's graph. All right, 4 pi. When 4 pi went in, 1 came out. So when 4 pi went into cosine, 1 came out. So when 4 pi goes into secant, the reciprocal of 1 comes out, which is 1. So this will be a point that lives on both of their graph. All right, let's go this way. When negative pi over 2 went into cosine, 0 came out. So when negative pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that'll be a VA on the secant function's graph. All right, when negative pi went into cosine, -1 came out. So when negative pi goes into secant, the reciprocal of -1 comes out, which is -1. So that'll be a point that lives on both of their graphs. All right, when -3 pi over 2 went into cosine, 0 came out. So when -3 pi over 2 goes into secant, the reciprocal of 0 comes out, which is undefined. So that'll be a VA on the secant function's graph. All right, and then last point, when -2 pi went into cosine, 1 came out. So when -2 pi goes into secant, the reciprocal of 1 will come out, which is 1. And that'll be a point that lives on both of their graphs. All right, so now let's figure this out. Let's go here first. Let's go right here at 0, 1. So same thing's going to happen. When you take all of these y values that live on this hill here, and you take the reciprocal of all these y values, it's going to flip them up. Same thing, there's an angle here that made 1/2 come out. So when that angle goes into secant, the reciprocal of 1/2 will come out, which is 2. Same thing, some angle made 1/2 come out, so when that angle goes into secant, the reciprocal of 1/2 comes out. So there is your up parabola, if you will, for lack of a better word. All right, and then same thing here. So what's going to happen is when you plug all these angles into secant, it's going to take all of these y values on cosine, and you're going to take the reciprocal of them, and it's going to flip them over, and now they're going to flip down. And then all of these are going to flip up. And then all of these are going to flip down. And then all of these are going to flip up. And that's your pattern. And same thing, all of these y values, when you take the reciprocal of them, are going to flip over and go down. All of these y values, when you reciprocate them, are going to flip up. All right, so that is what the secant function graph looks like. So his first cycle doesn't start at 0. It actually is, his first cycle is right here, and we say it goes from -pi over 2 to 3 pi over 2 is his first cycle of that up-down parabola. So the major difference is cosecant starts with a VA at 0, 0 because sine starts at 0, 0. All right, and then cosine does not start at a VA. It actually starts shifted back at -pi over 2. Okay? All right, perfect. Let's fill in his information and be done. All right, so his domain. Guys, he's got lots of bad angles, right? X can't be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, -pi over 2. Odd integer multiples of pi over 2. So the first bad guy is pi over 2. And then plus or minus, every bad angle is pi radians away from him. So pi times k rotations. So X cannot be odd integer multiples of pi over 2. Okay? All right, his range, same thing. It's going from -infinity to -1, huge gap, picks back up at 1 to infinity. So all of these y values do not come out of his function. So -infinity to -1, including -1, union 1 to infinity. Okay? All right, let's do his period. His period, to get one cycle, takes how many outputs? Well, -pi over 2 to to 3 pi over 2 is still 2 pi radians big. The difference in between that is a difference or a distance of 2 pi radians. The amplitude is NA when you have that whole infinity and negative infinity thing going on. His x-intercepts, he does not have any x-intercepts because of this huge gap. No x values make a y value of 0 come out. So none. He doesn't cross the x-axis. All right, his y-intercept, he actually has one right here at 0, 1. Okay? He is, if you remember, the cosine function was even. So being that secant is his reciprocal, he's also even, right? Think about it. When pi went in, negative 1 came out. When the opposite of pi went in, when the opposite of x went in, negative 1 still came out. That is even function behavior. And he has symmetry to the y-axis. All right, VAs, he's got ton. He's got a VA at 1 pi over 2, 3 pi over 2, 5 pi over 2. All the x's that are not in his domain create VAs. So he will have VAs at x equals pi over 2 plus or minus pi radians away times k rotations. So x will equal odd integer multiples of pi over 2 will be all of his VAs. Okay? All right, his 4 main subintervals, well, same thing, except it's a little bit shifted. All right, 2 pi divided by 4, you still count by pi's over 2. So we have 1, 2, 3, 4 main subintervals on his first cycle. The first main subinterval is from negative pi over 2 to 0. All right, the next one is from 0 to pi over 2. The next one is pi over 2 to pi. And then the last one is from pi to 3 pi over 2. All right, and then his 5 key points, if you will, even though some of them are asymptotes, is negative pi over 2 went in, and an undefined ratio came out, so that creates a VA. You have the point 0, 1. On his first cycle, you have the point pi over 2 undefined, so another VA. You have the point pi negative 1. And then you have the point 3 pi over 2 undefined, so another VA on his graph. All right, and those are the key points that you could use to create transformations in the future if you wanted to whip up a quick sketch. So just remember, he starts a little bit behind 0, up, down, and so on. So again, their graphs are very similar. They just don't start in the same spot, just like the sine and cosine wave didn't start in the same spot. Okay, so those are your 5. Now you've seen all the graphs of all of your trig functions, and then you'll be asked to transform them. Please reach out to me if you have any questions on any of their graphs. Good luck, guys.